All right, here's another function to integrate. And now I've got a sort of a power function times a trig function. And the power function is what I would consider an algebraic function. And it comes before trig functions. So by my Lie rule, I'm going to let u equal x squared. And I'm going to let dv equal sine of 4x dx. Okay, and so then if I differentiate u, I get du is equal to 2x dx. And then I integrate this v dv, and now I'm going to get minus 1/4 cosine of 4x. Okay, so now I have u and v, and so my integral is going to be, I'm going to get u times v, so x, actually I'm going to write the coefficient out front. So I'm going to get minus 1/4 times, okay, x squared, right, u times v. All right, minus 1/4 times x squared times cosine of 4x. Okay, and then I'm going to subtract the integral, right, which is going to be v du. So minus, trying to figure out what I have here. Minus, I'm going to v du. Okay, so I got minus 1/4 cosine of 4x. That's my v. And then my du is 2x dx. Okay, I can simplify that a little bit. I can, first of all, I've got this minus and negative, so I'm going to make those positive. And then I can make this into 1/2 and cancel this too. All right, so let me rewrite that so it looks a little nicer. I get minus 1/4 x squared cosine of 4x plus, let's see, I'm going to bring the 1/2 out front. And then I'm going to get the integral of x cosine of 4x dx. All right, well, I still don't know how to do this, right? So oftentimes you have to apply integration by parts more than once. Okay, so I'm going to do it again because I still don't know how to integrate x cosine 4x dx, right? So I'm going to do the same thing again. I'm going to let u equal x, so du is equal to dx. I'm going to let v equal cosine of 4x dx. Oops. Oh, dv. I'm missing the dv. dx, right? And so then v is the integral of that, which is going to give me 1/4 sine of 4x. Okay. So now I'm just going to work with this this integral part of it. I want to sort of hold this for later, right? I could even put a little square around it or something, a box around it, so I don't forget about it, right? Because now I'm just working with this other integral here. So when I do that, I've got 1/2, all right, and then I'm going to take u times v, so that's 1/4 x sine of 4x, okay, minus the integral, and I'm going to get v du, right? So that's 1/4 sine of 4x dx. Okay, so now I've got everything in terms of something I can integrate. I can integrate this 1/4 sine of 4x. All right, so I'm going to put this all back together here, so I'm going to get minus 1/4 x squared cosine of 4x, all right, and then I have plus 1/2 times this whole quantity, all right, 1/4 x sine of 4x, and then I'm going to have minus, okay, so it's basically minus 1/4, and then I'm going to get times the integral of sine is the minus cosine, so this becomes a positive, And then I'm going to get 1/4 times that. So 1/4 times 1/4. I'm just going to clean this up so that I don't have to rewrite it. All right, so this becomes 1/16. Right, and integral is as cosine 4x. All right, all of that's times minus 1 or times 1/2, and then plus c because it's an indefinite integral, so we can't forget the plus c. Now I could probably clean that up a little more. I could distribute the 1/2. There's a bunch of fractions here, but this is good enough. I don't have to. If I don't have to, I won't. I don't want to do more work than I have to. So there you go. There's the integral. And in this case, we had to apply integration by parts twice.